Hello and welcome to today's video. So on the battery pack today, we have the Pack Sniffer 2, and if we follow the cable, it's plugged into the back data connector there for the Nissan Leaf battery pack. And the other cable goes nowhere, so you can kind of ignore that. So you've seen this before, we'll go ahead and fire it up. So yeah, we don't have an SD card. So bootloader skips the application. We're going to find our BMS. We're going to start reading it. We'll see that we're at 378 volts with 0 amps flowing, which is good because it's not hooked to anything. Those are our temperature sensors. I got 24C, 23C, and temperature probe 3 doesn't exist. That's why it reads negative. That state of charge and health looks very suspicious since it's 567 and 987. Those are our high and low cells. Those look pretty legit. So our average is 3.936 volts, and our span is 18 millivolts between the high and low cell. And then we're just going to start counting all of our cells. Well, and displaying the voltages for each one. But yeah, that all looks good. So that really suspicious values were the state of charge and the battery health. And that's because those are the values that are typically spit out by my battery pack simulator. So this is one of my real-time motion control. It's a servo controller, and I wrote some code for the micro to emulate the battery pack over CAN bus. So yeah, that's essentially what we're doing, because that is the actual BMS for this battery pack, which means we're running off of my modified BMS. And the only thing that's modified on it right now is I replaced Nissan's microcontroller with my own. So you can see that purple interposer board there is going from their 100-pin QFN or 100-pin thin quad flat pack package to my 64-pin QFN package. And then the big connector, here's the programming/debug connector. So just kind of ignore that. Normally that wouldn't be populated. I don't have a bootloader. That'd be the next thing I need to write, is actually a bootloader for this. But to get the truck up and running, I think we're going to skip that for now. I can always open it up and program. I can work on another one. Then when it's done, I can program this with a bootloader, and that would make life easier. My goal is to have the Pack Sniffer 2 actually be able to program it over CAN bus. Everything, actually, if you plug the SD card in there, it will check the firmware on everybody or get the firmware checksum, and then be able to field upgrade everybody over CAN bus, which will be great. So then you have to actually take it apart and plug a programmer into it. But anyways, yeah, it's all working now. So I guess I can do a quick little overview here. We've got the micros talking over CAN bus, which is this chip here, out the connector all the way around back to the Pack Sniffer 2. We're also doing LIN bus, which goes through this optocoupler, goes through the first batch of 12 chips. There's 6 on this side and 6 on the other, and they kind of daisy chain back and forth. Those read the, this is the back section of the battery pack. So these two connectors are going to all of those guys. And then we go through this optocoupler, which allows us to pull out the main disconnect. Without that, and if anything was drawing current, it would go through this balance chip through that guy and it would pop them. So that opto isolator prevents that from happening. And then we go through the next 12, 6 on this side, 6 on the other, another opto isolator, and then back around over to the microcontroller again. So the LIN bus is kind of like it's a big daisy chain they pass along. It took a while to get the code working on that. So you got to send out packets, and you have to have the right checksum and calculate. It's actually a CRC polynomial number 85 is the actual checksum that it's looking for. And once I got all that working, I'm able to read all of the chips. I had originally decoded, there was a video that I did a long time ago where I had my battery pack simulator or battery cell simulator hooked up, where it was I was actually adjusting. I had little pots that I was adjusting cells 96, 95, 94, 93, which is the closest ones to ground, so I wouldn't electrocute myself. And those ones, I was able to sniff the LIN bus while that was happening, and was able to reverse engineer what those packets meant. And so now I can read them all. I mean, they're super accurate. Each one of these things is I think it's 10 volt or 10-bit converter for every cell. So to come up with the main stack voltage, I just add all of these together and essentially divide by 96. But yeah, that's all working. We are reading the temperature sensors. Like I said, this battery pack only has 3 temperature probes, but there are provisions for 4, so I did all 4. In my implementation, I will have all 4 temperature sensors hooked up to both BMS. I'm going to have 2 BMSs. Let's see what else we've got. I have control over the heater relay, which is located underneath the. It's underneath there. I can turn that on and off. I can read all of the I/O. There's a bunch of like little interconnect switches that tell you when high voltage connectors are unplugged. So I can read that as just regular random I/O. What else do we have? So we can read the current sensor, everything. Oh, I even have the insulation monitor system hooked up. So that's what this section is. So the micro puts out a 2 hertz square wave, and it goes out onto the battery pack somewhere. I haven't actually traced it out, but it's probably going through there. It could be through, there's a bunch of caps here in series, a bunch of caps here in series, and then there's like another bunch of caps over here in series. So it might be going out through here and then read back, or vice versa. It might go out and then get read back. Like it might go out in those 3 sections and then read back over the caps. That's probably more likely as it gets read back this way. But essentially what that does is the micro sends out a square wave, and then it actually sees another square wave that comes back that's actually inverted. It's like 180 degrees out of phase. And I'm guessing that if you were to short any one cell to ground or 12 volts on the BMS, because this section's isolated. So if there's any connection between this to this, those would become in phase. That square wave would become in phase, and you'd know that you have a short between your, or you'd have an insulation breakdown. So if like one of your cables were to chafe on the edge and make contact, then boom, you would instantly know that that something's been compromised. So that works. That's pretty cool. I haven't actually tried it, but it is spitting out the 2 hertz square wave. But yeah, I think we've got everything. Yeah, I think everything's good to go. So it can go. Oh, it's about to reset here. Here, let me do this really quick. So I put my finger on the temperature sensor, and when it reads it, it'll see the one will be higher. It's pretty cool. I did all that work. Yeah, see now temperature 1 is 30 degrees C, and the other ones are 23. And they're amazingly accurate. Like, I went through all that trouble of making the little graphs and heating them up and putting them on ice and stuff. But if we go over to the temperature on it is actually, if you look, it's 20, 22, and it's right in the middle. It's 23 degrees Celsius. So it's they are pretty amazingly accurate. I mean, you have like no idea. Like if you look at it dead on, it's like exactly in the middle there. Yeah, I know. I'm quite proud of that. So yeah, so I think we're all done with that. So if you watched the last video, I had the battery charger charging. So the patch sniffer 2 is able to control the battery charger. So now this has everything it needs. So we can read all the cells. We can read the highest cell. We can control all the balancers. Oh, that's what I forgot to mention. I can control all 96 balancing resistors on there. So I've got full control over that. It accepts the commands. We're calculating the checksum correctly. Everything on that looks like it works. Looks great. So I think that's good. So the next step is I need to take this battery pack apart because I no longer need it. We can just take that apart. And I need to build another one of these guys. It'll be like a mirror image of it. So if you were to take this and just rotate it, but then wire it the opposite way, because I want like grounds to be on the same side. So I don't want that to be ground, and on the other one 150 volts, I want ground, and 150. But I do want to make the BMS pinouts for both connections identical, because I've got cables that'll plug into here and here, so I can make new ones. Then the BMS will live on top of it somewhere, maybe in here. There'll be a gap when they're in the truck. These ones are going to take more time. I have to take the 4 out of the middle, and I'm going to have to do some cutting and stuff, and I got to take them all apart. So that'll probably be phase 2. Plus, I got to modify my front battery box to fit a double stack, so that will get stacked on top of this guy. And that'll be a little too tall for my current battery box. There's enough room. I've got clearance to actually do it. I just got to make a new battery box cover for the front, so that might be delayed a little bit. But the front battery pack will I'll have to wire it up, and then it gets its own BMS. So I'm going to have, like I said, I'll have 2 of these guys in there. And yeah, it's getting really close. So I think that's it. We've got, we're able to read all the cells. We're able to balance the cells. And we can control the battery charger, NLG5 battery charger. So we should be able to tell it to start charging. And when one cell hits our voltage cutoff, we can turn off the battery charger, and then we can balance all the high ones down. I think we're good. I think we're ready. So anyways, yeah, it's exciting. But yeah, thanks for watching. Bye.